In this lecture video, I got two examples here where I'm going to show you how to simplify these expression, okay, using scientific notation. So rather than multiply this straight up, we're going to actually multiply it through scientific notation. So again, the purpose of scientific notation is really a shorthand notation for either a very large number or for a very small number. As you can see, mathematicians are kind of lazy. They don't want to keep on writing all these zeros. That's the reason why they create a shorthand notation to kind of help them do the math a little bit quicker. All right, so I'm going to show you how to do this by hand, and then I'm going to go to the calculator once I find my answer. All right, so convert each one of these numbers into scientific notation. So for the 467,000, this number is bigger than 1, so I know my exponent will be positive. So the number in front of times 10, let's see, this decimal is here. I need to move this decimal between the 4 and the 6, okay, in order for this number in front of times 10 stays between 1 to 10. So that will be 4.67 times 10 to the how many power? Well, let's see how many places I'm going to move. 1, 2, 3, 4, 5 places. So, all right. So I convert this number into scientific notation and times. Okay. I'm going to purposely not to write a parenthesis right here, but we kind of know this comes from the first number. I think if you read the tutorial, they will purposely put the parenthesis here. I don't want to do that because we spent a lot of time in the previous module trying to get rid of the parenthesis. So I really don't think adding parentheses here is appropriate. All right, but instead I'm going to color code this, okay? Times, all right, for the 0.0002, let's convert into scientific notation. It's going to be something times 10 to some sort of exponent. So since this number is between 0 and 1, I know my exponent will be negative. So where should I move this decimal to? If I move this decimal in front of the 2, then that will be 0.2, which I cannot do because this number in front of times 10 always got to be between 1 to 10. So the decimal got to naturally go behind my 2. So basically I have a 2 times 10 to the what power? Well, let's see how many places I need to move. 1, 2, 3, 4 places. So I'm not saying I need to move to the right or moving to the left. What I'm saying is we need to move the decimal, okay, to the right or left according to the actual number, whether it's bigger than 1 or lesser than 1, in order to keep the number in front of times 10 stays between 1 to 10. All right, so basically now what we are having ourselves here is basically take the 4.67 times the 2, and then once I figure out what the answer is, then I'm going to take a look at 10 to the 5th power times 10 to the negative 4 power. All right, so real quick, 2 times 4.67, 2 times 4.67 will give me 9.34. So my final answer is 9.34 times 10 to the, okay, so now when the base are the same and the base are multiplying, we add their exponent. So 5 plus negative 4 will be positive 1 power. So that means my final answer expressed as a scientific notation will be 9.34 times 10 to the 1st power. Okay, now what happened if I would just put this in the calculator? 467,000 times 0.000 times 2. That would just simply give me 93.4. All right, so looking from the 93.4 perspective, to write this as a scientific notation, it got to be something times 10 to some sort of exponent. And my exponent got to be positive because this 93 is bigger than 1. So my decimal got to be moved between 9 and 3 to keep the number in front of the times 10 as between 1 to 10. So if I only move one place, my exponent will be 1. So this gives me the same answer. All right, let's try with the division, okay? Again, I'm going to do this by hand real quick. Then I'm going to put in the calculator. All right, 61,000. So I know it's going to be 6.1. because I need to move my decimal from behind the 0 to between 6 and 1. How many places will I move? 1, 2, 3, 4 places. Now take that divided by 0.001. The decimal need to be behind the 1. So that will give me 1 times 10 to the negative. It's negative exponent because this number started with 0 point something. 1, 2, 3 places. Very good. All right, so let's do the numerical part, then we'll do the exponent part. What's 6.1 divided by 1? Still got to be what? 6.1, right? Times 10 to the, when the base are the same base of dividing, we subtract the exponent. So when it comes to subtracting exponent, it's always going to be the top exponent subtracts the bottom one. All right, or you can just flip the 10 to the negative 3 power to the top, and you will notice you got 10, you got 4 10s multiplied together, and another 3 just moved to the top. So altogether, you should have 7 of those 10s multiplied with each other. Okay, so that's my answer: 6.1 times 10 to the 7th power. So if I will key in this number, key in this problem in the calculator originally, sometimes it might work, sometimes it doesn't work. It really depends. Okay. All right, it doesn't work. It's just telling me that I have, let's see, 61. Let me see, yeah, 61 million. All right, but you can kind of tell. Okay, 61 million. I got 6 zeros, but why is 7 power? Because a decimal need to be between 6 and the 1, so I need to move 1 additional place, and that's why. That's why just by looking at this, the exponent should be 7 power, because the 6 places I move covers 6 zeros, but I need to move 1 more place, okay, to have 6.1. All right, that's why it's to the 7 power, just by looking at the calculator. So just real quick, how we can actually do our multiplication and division by convert them into scientific notation, so we can quickly do our operation, our numerical operation that's up front quickly. All right, that will conclude this quick lecture video about scientific notation. Thank you for watching.